Hello, welcome back to Mastering Statistics. Here we're going to put everything together with this hypothesis testing that we're going to do involving two variances. We'll be using the F distribution to figure out how to set these tests up, and we'll be starting off with a right-tail test. And if you've been following all of my lessons in hypothesis testing, which you really have to understand this material, so go back and review that if you haven't already, you know that there are right-tail test, left-tail test, and two-tail test. And the type of test you have is really just going to depend upon the problem. So right now, our problems are going to start off with the right-tail test. Let me show you what I'm talking about. Essentially, you have this thing called the F distribution, which is the kind of distribution that we use when we have tests involving two variances. So this is the F distribution, and as you remember from the last section, it's very skewed. It has a big hump and then it has a tail off like this. And ultimately, we're going to use the concept of rejection regions, which we've used all up until now in hypothesis testing. So there's this critical value of F. We don't call it critical value, we call it F sub alpha. And the reason we call it F sub alpha is because it's the value of F that you end up reading off of the table that gives you an area under the curve to the right, always to the right, of alpha. And alpha is our level of significance, right? Which is basically related to the level of confidence. So if you're doing a 99% confidence test or a 95% confidence test, then this value of alpha is going to be different. So the shaded area will be different, and then the F sub alpha, the critical value, is going to be different for those problems also. So if you remember back, we've done this before when we did rejection regions. So there's this critical value here, and it lines up with F sub alpha here. So everything to the right, if we calculate our test statistic and we get a value over here, we'll reject the null hypothesis. All right, so if we get a value of for our test statistic over here, we'll reject the null hypothesis. Remember, everything in hypothesis testing is always, do you reject the null hypothesis or do you fail to reject it? And if you get a value in your test statistic over here, you will fail to reject the null hypothesis. So essentially, the problem is going to give you enough information to figure out what F sub alpha is, and then your data is also going to give you enough information to figure out where your test statistic lies. If you get a test statistic anywhere over here, then you're going to have enough evidence at this level of significance to reject the null hypothesis. And if you get a test statistic from your data over here, you're going to not be able to reject it. You're going to fail to reject that null hypothesis. And then in those cases, when we get to an actual problem, we'll talk about the conclusions. Now remember, for these types of problems, the test statistic, and I've kind of mentioned this before because I had to when I introduced the F distribution, is going to be F is equal to S1 squared over S2 squared. Remember, we're sampling and we're getting a sample variance. So S1 squared is the variance from population 1 that we've sampled, and S2 squared is the variance that we calculate from the data we collect from population number 2. We just divide them. That's all you're doing. You take population number 1, population 2, and you divide them. You get a test statistic. Either it's going to fall here or it's going to fall here, and this is your hurdle. This is the hurdle that you jump over. I like to refer to it as the hurdle because essentially it's telling you what number you have to cross, what threshold is statistically significant for your data. We'll get into some problems in a second. And just to kind of write it all down, if you get a test statistic that's greater than F sub alpha for a right-tail test, then you're going to be in this shaded region, and that's going to mean that you reject the null hypothesis. Basically, it's what I wrote up here. And then if you get a value of F that's going to be less than F sub alpha, then you're going to fail to reject. Or less than or equal. You're going to fail to reject the null hypothesis. All right? So what I'm going to do now is keep this picture in your mind. Let's go on to the next slide here, and then we're going to actually do a problem to put it all together. So here's our first real problem. We have two plants, and they produce pencils. A manager thinks that plant A is malfunctioning, and that the variance, notice the word variance, in the pencil length at plant A is greater than the variance of the pencil length in plant B. Okay, so what does he do? He thinks this is the case, so what does he do? He samples 20 pencils from each plant, 20 pencils from plant A, 20 pencils from plant B. Plant A has a sample variance. Notice we use the word sample variance because we don't look at every single pencil coming off